yeah, you can see that the recording is in progress. Before I begin, I like to start with land acknowledgement. So I'd like to acknowledge that the University of Guelph is situated in traditional territory of the Neutral and Anishinaabe, Haudenosaunee, and Métis people. Today, this place is home to many First Nations, and acknowledging them reminds us of our important connection to each other and our shared responsibility to this land where we live, learn, and work. This webinar is part of the Ontario Agri-Food Innovation Alliance KTT grant that we have been implementing in collaboration with the School of Animal Science. And I'd like to also mention that today, my colleague, Dr. Humayun Kabir, will be helping us to facilitate this session. I want to invite Dr. Kabir then begin with your logistic and to introduce the speakers and what we will be probably expecting out of this session of the webinar series.
Yeah, thank you, Professor Chaudhary. Good afternoon, everyone. I'm Dr. Khandakar Kabir, a postdoctoral fellow from School of Environmental Design and Rural Development at University of Guelph. I will be moderating the next session, which will be split into two sections. So in our first section, our invited guest will give their presentation, and then they will join together for a panel discussion in our second section. So I would like to request you to post your question in the Zoom chat box for our panelists. And also you can raise your virtual hand, open up your camera, and you can ask question directly to our speaker. So I would like to remind you again that this webinar is recorded for future references. Now I would like to introduce our speaker of today's webinar. First, let me introduce Professor Dominique from University of Guelph's Department of Animal Bioscience. Professor Dominique has been working in aquaculture for 20 years and has a lot of theoretical and practical experiences. His research aims to increase our understanding on nutrient uptake and deposition, feed and nutrient need, as well as waste management for fish and shrimp. So I personally welcome Professor Dominique.
Thank you very much.
Yeah, our second speaker is Mr. Roy Hines, who is the owner of Norcan Electrical System. We know Norcan Electrical System is a leading provider of centralized fish feeding system for aquaculture industry globally, not only in Canada. They also support farmers with underwater camera system. So Mr. Roy has experience with aquaculture industry in Canada over the last 30 years. I also welcome Mr. Roy. So today with Mr. Roy, Mr. Jordan Bryden will give the presentation. So I welcome both Mr. Roy and Jordan to our webinar.
Thank you.
Yeah. So that's all I have to say about our presenter. So I'm very excited and don't want to keep you waiting any longer. So now I would like to hand over the virtual floor to Professor Dominique for his presentation. So the Professor Dominique, the virtual floor is yours.
Thank you very much. You all see my screen? Guess the most common questions. All right.
Yeah, perfect.
So I want to give a brief overview of basically the role of technology in improving productivity and sustainability of fish culture in Ontario with a broad topic. In Ontario, we have a small but vibrant aquaculture industry, mostly involving the production of rainbow trout in net pen or cages in the Georgian Bay area or around Parry Sound or Manitoulin Island. About 6,000 metric ton of product, fish from 1 to 2 kilograms in size, I imagine. Now, this industry is supported by a relatively limited number of hatcheries or providing fingerlings to be stocking lakes. These hatcheries also operate land-based facilities and also sell food fish product to the market. We also have an industry that is also quite diversified with a number of farms that cultivate tilapia, barramundi, yellow perch, and other species. And we have government fish culture stations operated by the Ministry of Natural Resources and Forestry, which operate 9 or 10 fish culture stations for basically stock rehabilitations, culture of native and introduced species in our bodies. So we do have a small aquaculture industry, but I like it to describe it as being vibrant and kind of locally owned, as opposed to what's happening on the East Coast and West Coast of Canada or happening in Norway or Chile. We have local players, local industry players, and relatively a very small and very small industry that is very easy to relate to. And that has a very big impact locally and provincially on the economy. Now, the conditions in which we're producing fish are really quite diverse. I guess when you talk about variation across season, and I don't know many places around the world where they farm fish where the water temperature is down to close to 0 degrees Celsius and everything is covered with snow and still are able to produce fish. So that's kind of a salute to our producers who are able to produce a sizable amount of production in very harsh conditions, varying from very cold during the winter to really quite hot during the summer, really at the limit of the physiology of the animal during this period of time, especially. These operations face many challenges and decide to focus mostly on net pens, but many of the same challenge can be said of land-based facilities. Basically, they operate in an open environment, so they are kind of subject to environmental or the victims of environmental variations from very cold winter to very warm summers, but also needs to be good environmental steward because the waste are directly released in the public domain, and therefore operations are held to very high standard in terms of environmental stewardship, reporting, licensing, and etc. So that makes it really quite challenging for the environment to be operating in a natural environment, both from a kind of receiving end and kind of giving end. They are using very expensive feed for the price of commodities being what they are today. Dairy feed is extremely expensive, and price of products are relatively quite stable. Many of these farms are operating in remote region, and sometimes they even operating offshore, several kilometers or several hundreds of meters offshore, and that creates a number of issues. As opposed to many of the other fish farms or salmon and trout farm around the world, most of our industries is operating using relatively low-tech, locally built equipment, and don't have the reliance that Norwegian and Chilean fish farmers, for example, have on very sophisticated farming system, feeding equipment, monitoring equipment. Another issue is the workforce located in remote regions, so access to trained workforce or things can be an issue. And this workforce is responsible for feeding very expensive feed and producing very expensive fish. So therefore, that brings a number of challenges. And then you have these relatively large net pens floating in the natural environment. And it's really quite difficult to estimate the fish crop, how big they are, how many fish there are, how hungry they are they fully satisfied, how much waste is coming out, etc., how much mortality do we have. Perhaps our industry is a little bit, quite a bit better than other industries. For example, we work very closely with shrimp farmers in Asia, for example. That's a lot bigger problem. But still, inventory control, prediction, forecasting is a major issue for aquaculture operation nowadays. Now, technology can play a role in addressing many of these challenges. And I like to present technology as kind of an evolution, right, of practices. We started with manual practices, right? Things, to extend the analogy, we're writing information using pen and paper. We move on to more mechanical means, right? The typewriter or being kind of the example. And now today we're moving a lot more towards digital means, integrating technologies, the mechanical part with a kind of digital part or the computer part to the technology that makes the technology more powerful. If we take this evolution and apply it to feeding management, well, we can say, well, initially, a lot of the feeding, all the feeding was done by hand, all manually. And it's still the case in many operations. We're still relying a lot on hand feeding. I don't know how extensively in Ontario it is, but I'm sure on land-based facility, a lot of hand feeding is involved. Now, there's been a number of mechanizations and implementation of equipment to facilitate the feeding, from very simple mechanized feeders like the Ziegler belt feeder, for example, or the widely used, which is basically you load a certain amount of feed and you let the feeder distribute that feed over time, or the use of demand feeders where you let the animal hit the pendulum and feed themselves and decide how much you feed, to a more mechanized and automatized feeders, or really quite mechanized feeders like the feed blowers that we see here in the picture in Manitoulin, in the Big Sound at Aquaculture Fisheries, where basically an operator is operating a relatively large feed blower in order to feed the animal. Still, humans are involved in determining how much feed is fed and monitoring the animal. Now, around the world, there's been a true evolution in the feeding management systems where companies have developed demand feeders that are equipped with sensors in order to provide kind of a feedback loop and to determine how hungry the animal are and predetermine a ration associated with the interaction of fish with the sensors, right up to the use of very highly mechanized and automatized feeding systems that are driven by camera and even computer control system, artificial intelligent control system today, which control the feeding of cages and salmon, very commonly used in Norway, UK, west coast of Canada, and Chile, of course, optimizing this. Now, these systems have not been widely adopted in Ontario, but still they're likely going to be on the horizon very, very soon. There's different degrees of technology used, but clearly in Ontario, I think we're probably lagging a little bit behind in terms of application of these things, perhaps because of the size of our industry. In terms of inventory and biomass estimation and management, manual sampling, counting, using seining the fish and counting the fish, harvesting, doing grab sample has been widely used, or always been used, still widely used. There's been an amount of mechanization going on with fish pumps, fish counters, and etc. Counting, improving the process, speeding up the process, allowing more accurate counting of the animal, and this. And now, around the world, there's a number of technology companies developing more automatized system to estimate biomass, from frame that you suspend in water, the fish swim through the frame, and you can estimate their size, to sonar and other technologies that allows you to map the fish, map the animal, see the animal, or vision-based, computer vision-based system that allow you to basically count the number of animals, estimate the size, which are being implemented in various things. Still, in Ontario, not widely used, that technology is not widely used. We're more relying on mechanical or manual ways of estimating the number of animals. So likely we're going to be evolving to use of this more advanced system in the future. In terms of data acquisitions and production management, I think that's where the same analogy can be drawn. A lot of the information is compiled on forms, on papers. Things have been mechanized and improved through the use of spreadsheets and computers, of course, so everybody is inputting data into a spreadsheet. The problem with spreadsheet is that they're idiosyncratic, meaning everybody has their own spreadsheet and you can create multiple copies of the same spreadsheet. And nobody can make sense of somebody else's spreadsheets and the way it's organized. So We've reviewed a lot of information from a variety of farms from around the world. What we found is everybody has different ways of computing even the most basic parameters. And therefore, that creates quite a bit of issues with trying to reconcile information. The other issue is that the data is often erroneous or contains some bias in terms of sampling, in terms of estimates of fish numbers, and etc. And that creates real management problem in terms of management and reporting. So there's been a number of digital systems that have been developed in order to simplify the data acquisition, the data compilation, analyses, and then make more of the data. Use the latest cutting edge science in order to analyze the information, audit, vet the information to weed out problematic data and support better decisions and more accurate reporting. One of the things that I see with these systems is that there's a little bit of over-multiplication of system. A lot of hardware companies involved in oxygen sensing equipment, water quality monitoring, feeding equipment, and the like are developing their own software associated with their hardware. So when you buy a piece of equipment, you're always buying it with a software that basically is supposed to allow you to track your inventory, your feeding management, and etc. And that might not be the ideal. Now, there's been a number of standalone data platforms from FishTalk, Mercatus, widely used in salmon farming, to Aqua Manager from Greece, which is really quite popular, another Greek company, Aquanetics, and our own homegrown Wittaya Aqua, which has a system, Aqua Farm, for fish farm, developed here in Ontario, where we're developing a software that is affordable and easy to use by a wide variety of farms, from the smallest farm to the largest farm. This multiplication of system is a little concerning in my opinion, because I remember during the pandemic, the little kebab shop beside my place had basically 6 or 7 different food delivery apps for selling, and they were selling maybe $200 or $300 of food per day. So actually that multiplication of technology, you buy technology, you have to use another system, another platform, etc., can actually become really cumbersome for the farm, for the end users. And really there's 3, like in our terms of computer or cell phone, we basically have 3 operating systems. It's been a lot of rationalization going on in the industry and the IT side of things. So I think there's going to be quite a bit of rationalization or mainstreaming of system in the coming years, where 1 or 2 or 3 systems will emerge as the key system, and hardware and other piece of equipment and other process will feed into these key systems. So kind of be a little bit of a winner takes all kind of situation going on probably eventually over the next decade or so. So how can technology, and specifically digital technology, help Ontario fish farm? I think we are going to discuss about this during the discussion, but I think there's great opportunity for improving the productivity and profitability on farm, from production planning to feeding management to the source support, which feed, which genetics, which farming practice, stocking density, stocking time, etc. You should be using what's the most profitable in terms of really enabling or improving environmental monitoring and impact monitoring and mitigation. I think technology can play a great role in it, and improving the outlook in this thing, or at least the vision or the ability of farm to objectively report how much impact they potentially have. Improving the transparency in this regard in terms of public facing information, reporting to regulatory agencies, smart reportings associated with smart regulations, I think would be important. Technology will play an important role in this. Certifications of aquaculture products is becoming very important for a number of markets, and therefore technology can play a great role in improving and making things more straightforward in terms of certification, and also interacting with the purchaser of the product and final user of the product to basically be able to have a traceability of that product, and being able to say, well, this fish came from this thing, and this is this history, and this is what it was fed, and this is what it was treated, could be a very important use and usefulness of the technology out there and things like that. A little plug with a system developed in Ontario. Wittaya Aqua is developing a suite of tools called Aqua and Aqua Farm, which cover the whole transect of feed right down to farm production to final product. And we're really creating what we call a digital ecosystem in order to be able to capture feed information and farm information, and integrate this information to meaningful end. And when we get into the weeds and we start analyzing data from farm, we realize it's extremely complex because you're using a succession of feed from starter to grower to finisher. You may be using feed for 2 or 3 different manufacturers in some case, growing and trying to compare crops that are producing in different seasons, like in this example from Chile that we analyzed. So we need the system, and then we're using feed of variable composition, which is an unknown composition to the farm, but known composition to the feed companies. And the feed companies may want to know how a certain nutritional specification, a certain type of ingredients affect productivity of the farm, profitability of the farm, and also environmental sustainability of the farm. So it's becoming really quite important to link feed information with farm information if we want to be serious about sustainability reporting. Technology also can be useful to audit farm data. This is a real example from Ontario Trout Farm that we analyzed a few years ago. And basically our models were able to detect anomalies or basically problem in data collections and reporting by the farm, where the farm thought the fish were a lot bigger than they really is, and our model were able to generate a lot more realistic growth trajectory for the animal and therefore be able to predict biomass more accurately. And our models can also be used to predict feed requirements and audit feed usage by farm, and therefore contrast what the farm is doing with versus what it should be doing, and basically identify whether feed wastage could have occurred or some issues with feed utilization, the impact of disease or weather patterns and etc. Affecting the feed utilization. So technology is very powerful. It could help farms deal with these challenges, especially in the context of global warming, changes in feed composition, etc., feed suppliers, etc. The other aspect is technology could be used to help us better understand the type of environmental changes associated with farming in a body of water. It's very complicated to link water quality changes with impact of farm. We were involved in work with the Freshwater Institute and the Department of Fisheries and Ocean many years ago. And it was very difficult to predict environmental changes associated with a certain amount of waste output. It was easy to predict waste output. And technology can help us kind of make sense, determine what impact, really true impact, a certain amount of waste will have on the environment. And I think that's the next frontier. And in order to do so, technologies, the farm need to adopt technology. So that was my overview of technologies and things, how it can be used by farm. And I look forward to the next presentation and our discussion.
Yeah, thank you, Professor Dominique. I think, yeah, we have enough time. Thank you very much for your engaging and interesting presentation. So to sum up your presentation briefly, I would have to say that technology is the key for management and productivity. So without technology, this sector cannot be get a good growth in future. So before I begin with Mr. Roy's presentation, I would like to hear your thoughts on two concern, our participants' thoughts on two concern. Please participate in our pool questions that I'm going to run right now. Just give your thoughts on these two important issues and that are really relevant with the presentation of Professor Dominique. Yeah, here it goes. I hope you can see the question in your screen. Just give your thoughts. What do you think about these two options? Do you think that this adoption of different digital technologies in rainbow trout farming is slow? Do you think that? And which factor in your opinion are most important in determining whether to adopt digital technologies or not. There are many issues, many factors, but I try to put some factors here so to get some overview from your responses. Good. Yeah, we get around 21 people respondents. Yeah, I will close within 20 seconds. Please try to complete your answer within this time frame. Okay. Around 30 people already respond. So we have around 50 participants. Okay, now I would like to close the poll. I don't know whether you can see the result or not. Yeah, I'm just sharing the result. So you can see that at least 60% of the people for participant thought that, yes, this adoption of digital technology is low. And 17% they mentioned that I don't know, actually, I don't know what to tell. And if you look at the factors, it's very interesting that characteristics of technology is the most important factors you consider, and also the economic factors. And also you mention about the farm characteristics and methods of information transfer. We will discuss later on this result. Okay, now I would like to request Mr. Roy and Mr. Jordan to take over the virtual floor for your presentation. So the virtual floor is yours. Please go ahead.
Okay, thank you. We'll get set up here and we'll share a screen, and we got a PowerPoint to present for everybody here. So just bear with me here. There you go. Can you guys see the screen?
Yeah, we can see. Maybe in the presentation mode, you can just click on the presentation mode.
Is there a presentation mode?
Yeah, in the right hand side of the screen, in the lower bottom, you can find a presentation mode here. Yeah, just go to, or you can carry on in that way, no problem. Just go ahead.
Yeah, sorry, I just
no problem, please go ahead.
Okay. Okay, so just bear with me here. We just put this PowerPoint together for you guys to show you kind of what we do and who we are and such. So I'll get right into it here. So welcome to our presentation. Thanks for having us. This is going to be presented by myself, Jordan Braden. I represent Norcan Electrical Systems, also known as Feeding Systems Canada. We are based out of Port Alberni, British Columbia, on Vancouver Island. And just if there's any questions, Roy and I will be around here at the end. And I mean, if necessary, you guys want to pitch in at any point, feel free to do so. But yeah, no, we are from Port Alberni, British Columbia on Vancouver Island. We have been designing and manufacturing customized centralized feeding systems for all types of fish farms and hatcheries since 1994. We have installed the feeders in dozens of countries and lots in Ontario, so we are pretty familiar with what's going on there, you know, as far as land-based and other types of systems. Yeah, like I said, both water and land-based facilities, as well as closed RAS facilities as well. So what is centralized feeding? So centralized feeding is feeding remote tanks. So all the tanks you see along here, raceways or net pens from centrally located feed storage silos. So how it works is the feed is transported through pipes, either pneumatically or hydraulically, via a network of pipes and valves. The pipes are typically made of high density polyethylene or stainless tube. So the pipes can be usually floated on water and or run down walkways or suspended overhead. Typically you see the suspended overhead in buildings and whatnot. So the main benefit of centralized feeding is it dramatically reduces operation costs and greatly improves feeding efficiency. So as you can see in this system here, there's the silos up there. Those are bulk storage silos. And it's about 2,000 feet to the pens from there. So the feed system is under the silos, and then it's blown out into the tanks here, about 1,000 feet. So yeah, with and then there's a couple valves, diverter valves on the in the cage system itself. I'll get into that a little bit more as we move along. So as far as the system overview and how it works, we got a little diagram here that will show you. So how it works here is each system is powered by a main blower or sometimes a water pump in the RAS systems. And how it works is the feed is metered into a hopper from one or multiple feed silos. So the feed drops through the feed silo and is pulled with usually it's a screw. In this diagram, it's called the feed regulator. So it delivers the exact quantities of feed down through the hopper, through the airlock valve, into the injector where it is blown through the main feed pipe and then diverted into all the cages. We do also build spreaders for the cages. Unfortunately, we missed some pictures on that, but that's how we distribute the feed around the cages. So yeah, moving on here. So as far as system types, this is actually just another view here of the system of this system here. Of the bulk silos, and underneath is all the screws and feed systems, and then the lake there. So as far as system types, we do containerized systems. What's nice about the containerized systems is if it's more or less a remote site and there's no big buildings or anything, you can put a containerized system anywhere on land, and there's no need to build a building around it. All you need is a good way to get the feed into the silos. And everything's protected underneath, type of thing. All the mechanical aspects and control is all protected from the weather. This is the skid systems that we do. These ones are what we do for where there's already a building on site. A lot of land-based systems have these, and as well as water-based systems. But as you can see there, it's a 4 silo system, all different sizes and different feeds and screws. There's the blower on there. Control panel over there to control the motors, and the semantic where the software's programmed into the HMI, the human machine interface. We also do early rearing systems with crumble feed for smaller fish. And we also do hydraulic systems for below surface feeding. So as far as, our potential applications, all of our systems, there's never really one system the same as the other, because all farms are a little bit different as far as layouts and amount of pens and species and all that. So, You know, we can change it up by how many blowers you need, you know, number and capacity of various feed silos and outlets and valves, etc. These are actually, we do have these are the rotary spreaders here. So these are what go out in the tanks. And essentially it's there's your polyethylene pipe going in, and then that air with the feed blows through and then spreads it around equally into the cages. So I'll just briefly touch up on the control side of things. So we call our control, it's the AutoFeeder V8 system. It's a Siemens PLC based system with Siemens Semantic Human Machine Interface, or HMI for short. So AF8 provides users with extensive control over the entire feeding process. It can be operated both manually or automatically. There are multiple tools and tables for calculating and tracking rationing, delivery, and growth. So AF8 uses a similar methodology as the thermal growth coefficient theory developed by Dominique and Cho Young for rationing and growth. This is just a picture here of the control panels and such. These are feed rationing and conversion management tables for tanks. So anyways, thanks for watching. We recognize the importance of efficiency in these systems. Feed costs represent a very significant proportion of costs in the aquaculture industry. So by basing our AutoFeeder models on the best known scientific models and data, combined with the best components and automation systems, this makes our AutoFeeder simply one of the most precise, most accurate, most reliable, centralized mechanical feeding systems. So again, thanks for watching. If you need to contact us, you can go through our website at norcansystems.com or phone. And if you have any further questions, Roy and I are here to answer your questions. Thank you.
Yeah, thank you, Jordan, for your efforts to give us a good overview about available technology for feeding management in Ontario Rainbow Trout producer. So now I would like to start our panel discussion. Before going into the panel discussion, I would like to request our participants that please drop your questions for our speaker to the Zoom chat box or raise your virtual hand. So maybe, yeah, we can spotlight Professor Dominique, and also just give me a moment. Yeah, okay, yeah, Professor Dominique is here, and also I'd like to bring Roy, and just